Friends, today we are going to discuss some centrifugal pump terminology which you need to understand thoroughly, because these parameters are required mainly to know the pump discharge power and pump required power. Here we are going to discuss three different type of heads. One is total static head, static suction head, static discharge head. What is static suction head? If you see the picture, here two different pictures are shown. First one is the picture where this is the pump. It takes suction from overhead tank. So the level of the overhead tank with respect to pump center line is called static suction head. Similarly, static discharge head is the distance or elevation difference between pump discharge pipeline up to pump center line. So this distance is called the static discharge head. And what is total static head? That is the difference between the elevation of the top of the pipeline to the overhead tank level. That is called total static head. In the similar way, in the second picture, if you see, the pump is taking suction from underground tank, and in this particular case we are going to call it static suction lift. That is the distance between pump center line to top of the underground fluid level. Similarly, the static discharge head is the level difference between the discharge between the discharge tank and pump center line. And total static head is the level difference between overhead tank level minus underground tank level. That is the total static head. These are the heads which we need to understand thoroughly, because this is required for calculating the pump discharge pressure and pump required pressure. Now the formulas, if you see the slides here, total head is referred as HT, capital HT minus plus minus HS. What is HT? Now it is called total discharge head. That is small ht. Small ht is your total discharge head. Small ht is your total static discharge head, plus h small h ft, that is called pressure drop in discharge line, plus discharge pressure of the tank or of the system. Similarly, the total suction head is equal to HS, small hs means static suction head, minus HFS means pressure drop in suction line, plus minus capital PS. Plus minus means it sometimes it can, the tank, suction tank can be operating in above atmospheric or below atmospheric. Then accordingly the symbol, according the plus minus symbol will appear. This is the picture where we have shown you the pump. It is taking suction from a tank whose elevation of supply, this is the elevation of supply reservoir, and this is the elevation of discharge reservoir. So the difference between these two is the static head. In this slides, I have shown you the pump which is discharging how much flow, that is 50 gallon per minute, and frictional resistance it has to overcome when it is running the distance from the tank to pump center line is 3 meter, and from pump center line to discharge to overhead tank is 302 meter. To when the flow will take place, so there will be pressure drop, frictional pressure drop, and that is equal to 58.2. And static head we have explained earlier, that is 61 minus suction head, that is 3 meter, that is 58 meter. 61 minus 3 is equal to 58, and now the total head is equal to 116.19. How this 116.19 has come, that we will explain now, because for this calculation 116.19 is the total head, that is HT minus plus minus H capital HS. What is HT? That is HT means static head. Static head is how much? That is 61 plus HFS, that is equal to friction. If when the flow will take place from pump discharge to the reservoir tank, there will be friction pressure drop. That is how much? Now total 57.8. 58.2 is the total pressure drop from suction reservoir to discharge reservoir. Here the 57.8 is the pressure drop from pump center line to discharge reservoir. What is the formula for calculating the pressure drop? Now FL V square by twice GD. What is F? Is frictional factor, L is total length, V is velocity of the fluid, by twice GD. G is acceleration, gravitational acceleration, and D is the internal diameter of the pipe. So for calculating the total discharge head, we have to add static, that is 61, plus frictional loss, that is 57.8, that will become 118.8. Similarly, static head I have already explained, 58, that is 61 minus 3, and that total, and suction head also we have explained, that is 3 minus the pressure drop of the suction line, that is 0.393, that is 2.607. So total head is equal to HT minus HS, that is 108 is 18.8, that is the discharge total discharge head minus total suction head is equal to 2.607, that is 116.19. This 116.19 has come like this. So this 116.19 will use for calculating the pump power, the discharge power and required power. In the next slide, I will show you the power. I have told you this formula is required, these parameters are required for calculating the power of pumps. So there are two types of power. One is called hydraulic or water horsepower, that pump, when the pump discharging some fluids, it is the power developed by the pump, that is called hydraulic or water horsepower. And what is brake horsepower? But to develop this hydraulic horsepower, you have to give more horsepower to the pump, because pump is having some efficiency. So pump output divided by the efficiency of the pump, that will give you the brake horsepower. And then what is the motor horsepower? Motor horsepower will be more than the brake horsepower, BHP, because there is some coupling losses, plus motor is having some efficiency. That's why the motor rating will be higher than the BHP. How much higher? That we'll discuss when we'll discuss API standard, API 610 standard. What is the formula to calculate the BHP? Now BHP formula is Q, specific gravity, Q is the flow, and unit is an empirical formula, Q is flow, and that unit is very important, that is gallon per minute, and H is differential head or simple head. Differential head, it is called, it should be in feet. It should be in feet. Specific gravity of water is equal to 1 divided by 3960 into efficiency. What is 3960 factor? This factor has come how? Now because BHP, if you see the horsepower definition is telling 33,000 foot-pound per minute. To lift a power article, 33,000 foot-pound per minute. So, and what is gallon? Now gallon is equal to 8.34 pounds. So if you divide the BHP formula by that is 33,000 by 8.34, you will get 3960. 3960. That 3960 factor has come like this, that 33,000 divided by as it is foot pound. So you have to convert the gallon into pound. 1 gallon is equal to 8.34 pounds. So if you divide these two, you will get 3960. Then our formula become how much? Now QH3960 divided by efficiency of the pump, that will give you the brake horsepower. Similarly, water horsepower, it is the pump generation power. So that is Q, simply specific gravity into a HT or differential head divided by 3960. There is no, it will be higher than this. So there is no higher than this. So this is the two formula we are use for calculating the water horsepower and brake horsepower. And efficiency is water horsepower divided by brake horsepower. Now, what is the definition of HP? Now, to lift a mass, how much? Now, 550 pound, 1 feet height in 1 second. What is the power required? That power is called horsepower. Similarly, in SI unit, it is called watt. To lift 1 Newton, 1 meter in 1 second, what is that power required is called watt. That is in SI unit per second. That is called SI unit. And the pump power means it is nothing but it is equal to the potential energy. What is potential? In class 11 and 12 you might have read the potential energy, kinetic energy. Potential energy means to lift a mass M from the ground level to a height h, the energy required, the energy stored in the of the item of the mass is called the potential energy. That is M. G is the against gravity. That's why gravitational acceleration into G 9.8 into height. So our in pump case also it is nothing but power means mgh. In SI unit, if you calculate the power, suppose a pump is handling 1 meter cube per hour water and pump to a head of 10 meter. 10 meter means 1 kg per centimeter square. Then what is the power discharge from the pump? That will be how much? Now 1 meter cube per hour into its density. Water density is at kg per meter cube into G. G means 9.81 meter per second square plus into height, that is 10 meter, divided by 3.6 into 10 to the power 6. How this 3.6 into 10 to the power 6 figure has come? Because this unit is here, it is hour, here it is second. So you have to convert this this into hour, divided by 3, that means 60 into 60, then 3600. Then you will get the hour. To convert the watt into kilowatt, again you have to divide it by 1000. So this 3.6 into 10 to the power 6 picture has come. So you can see now for the pump discharging 1 meter cube per hour for against 10 meter height is 0.027 kilowatt. Suppose you want to use this pump for discharging 10 meter cube per hour and 100 meter height, then what will be the figure? Now this into 10 into 10, that will give you your total power generated by the pump. So this figure is very important to remember. If you remember this figure, you can calculate the value, whatever parameter will be giving to you. You have to just simply multiply with this factor. Now, this is the empirical formula. And now if you are the imperial formula units or system, if you use this, then suppose you have a pump which is discharge. I have told you the Q you have to express in gallon per minute, that is 600. Suppose you are discharging 600 gallon per minute and height of 110 feet, and suppose pump efficiency is 60%, then specific gravity of the pump is 1. So pump power will be discharge BHP will be how much? Now 600 into 110 into 1 is the specific gravity divided by 3960 into efficiency is 0.6. So it will be 27.8 HP is required to give into pump shaft to get the output. So this is the brake horsepower need to be given to the pump. Now why this G factor has come? Because if you look into the, you know the power is equal to force into velocity, but even SI unit, when we are using SI unit, we are expressed it as a density, we are expressed it as a mass density, where kg per meter cube, which contain no G. Therefore, we have to multiply it with G, that is 9.81. That is for pump power is equal to how much? Now, Q rho means density, G into H. Or in imperial unit, density is expressed in weight density, means it is pound per feet cube. It is already includes G, already multiplied by G, includes G. Hence, there is no need of multiply by G. That for empirical formula, it is Q into H into specific gravity. So there is no need of any multiplication with G. So that is the difference. Now, I have already explained the terminology and how to calculate the BHP and WHP of pump. Now, if you have when you are appearing appearing in interview board, then these are the few questions you may be asked. That is, what is the power requirement of a fluid having high viscous fluid for the same flow when the pump is discharging, pump is used for discharging water. So you know the for viscous fluid, suppose you are using oil, and oil is less denser than the water because it floats on water. So power requirement of oil will be certainly be lesser than water because it directly depends on the density. Similarly, another question may be asked, that is, which one is greater, BHP or WHP? I have told you water HP is pump output. So to get this output, you have to give more power to the shaft divided by the efficiency of the divided by the efficiency of the pump. So BHP will be certainly be higher than the WHP. Suppose a pump is taking, another question may be taking suction from the underground tank, and in the same case the same pump is used to take suction from the same level. Which case the pump requirement will be more? Naturally, underground pump tank pump taking suction from underground pump will be high, because if you see the differential head, total head, it is discharge minus suction, suction level. So for underground, this value will be more than the pump taking from the suction on the same level. So naturally, the pump taking suction from the underground, where power requirement will be more, and then power requirement will be more. And how the 3960 factor has come, that I have already explained. If you are having any more question in your mind, then you can send it to my mobile number, and here is my mail ID. You can send it, and certainly I will give you the reply. Thank you very much.